Tēnā tātou katoa, ko wapori te maunga, ko pariora te awa, ko Ngāti Pakeha me Ngāti Kauwhata o Kuiwi, ko Warren King toku ingoa. I'm a research scientist based at Ruakura with AgResearch, and I'm here today to talk to you about the data supermarket. Now, the data supermarket comes out of, it's one of the outputs from the Whiri Ora program within the Our Land and Water National Science Challenge. And I just wanted to give the concept of the National Science Challenge as a bit of a plug. This is an opportunity for all of the science providers, the CRIs, other private science providers, universities as well, to collaborate in a really genuine and authentic way to collaborate on some of this country's most wicked problems. And I'm really sorry to see not just this challenge, but the challenge program itself finishing at the end of June. And I can only trust that the current review, which is underway in New Zealand Science, will allow for these kind of collaborations to continue into the future. And here ends the politicking. This is a very familiar context to me. My time in Australia was spent with a very similar to the National Science Challenges. They have a cooperative research centre program which has been funding collaborative programs in Australia on the big challenges with multi-party collaborations for nearly 30 years. So this is it might be new to New Zealand, but it's not new anywhere else. And the Whiri Ora program is a really large multi-party collaboration. So lots of people involved, as I say, CRIs, but also private research providers and some industry players as well. The data supermarket. This is a sales pitch. Only I'm trying to sell you something that you've already paid for. So this is a sales pitch, which is not really a sales pitch, but I'm here to provide you the keys, a bit of a rough guide to this data supermarket concept. The supermarket, as its name implies, has got a whole lot of data in it, some of which you've already seen this morning. But unless you know it's there, then it's pointless. It's the people in this room and your colleagues who will create value from this data. Scientists can create the data, can collate it, and can communicate it, but until it's in the hands of the people who actually can create value from it, the whole exercise is pointless. So this is this today as a whole, and particularly this presentation, is very much about wising you up to what's in here. This is the data supermarket. It was never supposed to be. This is a title we used as kind of informal shorthand for this process of trying to collate and gather together in a single place all of the data that came out of the Whiri Ora program. And yet, we couldn't come up with a better name, and the comms people got a hold of it, and they created a logo, and the die was cast. I should be wearing the damn t-shirt. But the data supermarket it is, and it actually the connotations from that name are correct. So what we've got here is it's a trolley scramble. It's free, fill your boots. So let's quickly have a bit of a guided tour through what the supermarket is. So clearly a repository for data. It's open access. Much of the data, but not all of it, is national coverage. It is open and freely available to you all, though there are some licensing restrictions for commercial use. But certainly you are able to look at and to use and to play with all of that data. It's transparent. So it's clear where the data's come from. So some of it, most of it in fact, is it's fresh data, but some of it is a collation of previous data that we thought needed to be gathered together as well. But those sources are made clear. The owners are made clear. And we've also made some commentary, and we'll get to this in a moment. We've also made clear what we think this data might be most appropriate to be used for. Now, it consists of a whole lot of different kinds of data. Reports, maps, tables, but also there's a lot of GIS shaped files in there. Actually, show of hands, who's currently got GIS software loaded on their computer? Oh, that's awesome. And who has access to GIS jockeys through their corporate or company kind of structures? Okay, so that gives me, I don't at the moment. I don't have GIS loaded on my computer, and so some of the maps that I'll put here are quite the low res kind of, when you land on a page it'll show you a low res image, but some of those shape files, some of those image files are really quite chunky, and you will need a GIS software package for some of them. So why do we need one? I think it was a leadership program in the American Army which pointed out that if you've got 30% of the data you need to make a decision, you might as well just toss a coin. If you've got 70% of the data you need, well, any monkey can do that. And so the vast amount of data that's becoming available and that you require to make sensible decisions around land use and land use change, this data supermarket, we hope, will provide data in a way that just shifts that dial, right? We want to be in the 70%, not in the 30%. And it's never been more important with changing regulatory environments and the focus on environmental performance. Now is better than tomorrow. Now is not as good as yesterday, of course. And this data is really for you and for your colleagues. It's not really designed for farmers, though there will be some farmers who will have a very happy time in this data supermarket. But many farmers will find it of limited use, particularly when it comes to the GIS layers. How might it be used? You tell me. It's up to you. This is a supermarket where we have populated all the shelves and we've opened the doors, and we're there to provide some support and guidance, and we're certainly here to answer questions, at least for the next little while. But as I say, fill your boots and then tell us what you've done with it. That would be really interesting. So what I want to do is have a quick gallop through some of the layers in the data supermarket. When I looked at it last night, this presentation was originally put together by one of my colleagues, Robin Dines, in November of last year, and we had 72 data layers. Well, now there's 92 data layers. So I don't know, even I don't know what's in there at the moment, and it just grows all the time. So we're going to have a quick gallop through it, but I wonder if you might. It's unforgivable. Right. Yeah, beer's on me, thanks. I need a jug of water to drop it into. So we're going to have a quick gallop through this, but while I'm doing this, I could only select the things that I knew about, the things that are really of interest to me, wearing my AgResearch hat. Clearly our principal focus is on pastoral agriculture, so I couldn't ignore those. But if there are specific things that you really want to know about, hopefully we'll get a chance to have a look at it live at the end of this, and so you can ask me, and we can have a quick kind of search through and have a look at it, just see what you think. But the first thing I just wanted to look at was through the lens of land use suitability and production. So this is 94 data sets. This is what the front page looks like. It's searchable, it's classified. You can see down the left-hand side there are a number of kind of descriptors of some of the data sets we've got in there. But just at the very top, well, A is for apple, right? So crop suitability, yield maps, crop suitability under climate change, economic indicators, they are all with respect to apple. So some of the other data sets for other crops, for pastures, for horticultural crops as well as arable crops as well, they will have multiple data layers in them. But I wanted to start with kiwi fruit. So this is the page that you see when you get into the kiwi fruit crops suitability and yield maps page. So there's a description, a date, it's got the authors there, Kumar, ex-AgResearch, now with Plant and Food Research, still based at Ruakura. Would welcome your emails, I'm sure, if you have any questions about this. But it's looking at the current suitability score for kiwi fruit and also a production potential for kiwi fruit as well, for the whole country. Now this is a fairly low res image, and the shape files, the GIS layers themselves, are a much higher resolution. So if you just want to cut out all of the South Island, because that's bonkers, right? And just look at the Upper North Island, for instance, or just look at the Bay of Plenty, or just look around a Potiki, that's well possible. Here's the report that sits in behind that, also available. Some metadata around this data set as well. So it talks about the resolution of that data. It talks about some of the resolution in terms of spatial and temporal resolution. It talks about some of the uncertainty, and there's some information there on the methodology as well. And this is true not only for kiwi fruit, but where we have that information available to us is true for every other data layer there as well. Importantly, we think we've given you some guidance on what we think is the appropriate use for this data. Is it appropriate to consider this paddock or that paddock with respect to kiwi fruit? The answer is clearly not. Is it appropriate is this data useful for consideration in a multi-farm context? Sure, and you can see there, screening, scoping opportunities. Is this something that is sort of in scope at that scale? Sure it is. At a catchment scale and at national scale for thinking about the relative performance of blocks, or at a catchment scale, thinking about the relative performance of them and whether it's in scope or even possible in that location. All of that is possible, but at a smaller scale, and for this data, we don't think that's appropriate. So these are guidelines. Test them. The next lens I just wanted to have a look through is the economic indicators. And again, I'll use the kiwi fruit example. So this comes from Simon Harris at Land Water People. And it's, again, a description, some dates, a link to the paper. Here's the report itself, which you are welcome to download and peruse at your leisure. What I just wanted to show here is that what Simon's done is look through an economic analysis of kiwi fruit. In this case, that red box just describes kiwi fruit gold versus kiwi fruit green under a number of parameters that describe those systems. Of course, this data is out of date. It was out of date the moment he wrote it down. But it's the relativity between these two systems which is important here. It's not the actual numbers. And you can argue the toss on any of the values in any of these particular cells, but it's helpful to try and consider the green versus gold scenario. Even more than that, there are some other considerations for thinking about kiwi fruit conversions from green to gold, from dairy to kiwi fruit, from kiwi fruit out into forestry, whatever it might be. Just in terms of the employment, household income, just a lot of other considerations. So this is, again, trying to move that dial with the amount of information that might be possible for you to think through the case for or against a kiwi fruit conversion. I like this one too, and this is the last in the sequence. I like this one because it reflects the maturity of the production system in a given case. So for instance, if we go kiwi fruit, okay, it's export market, all that stuff's really well developed, it's a well-worn pathway, we understand that the data is pretty reliable. We've been doing this for a while now, and there's a lot of infrastructure, a lot of consultants who know this stuff really well. So we think the degree of entrepreneurship required for a kiwi fruit conversion is pretty low. The risk around conversion into kiwi fruit is pretty low. We know how to do this. And farmers can be pretty comfortable that, providing they've got the capital to do it, it'll be probably successful. But there are other crops you can see here, chestnuts and other things, all those moderate to high, cabbage, broccoli, blueberry. The degree of entrepreneurship required from individual landowners to invest in those sorts of enterprises is considerably higher. The risk is considerably higher. So again, another layer, another lens through which you can look at the relative merits of converting or otherwise. Kiwi fruit's quite as I say, there's a lot going on in the kiwi fruit space. We know a lot, and there's an awful lot of data in that data set market around kiwi fruit, which, as an AgResearch employee and a pasture ecologist, I find of limited interest. We'll get to the grass stuff soon, don't worry. So here's a map, again, some of the other data layers, a map showing some of the operating profit. So this will be no surprise. The operating profit for gold kiwi fruit in Canterbury is quite low. But there's more. So there's an awful lot of environmental data, and some of which you've seen this already around E. coli, around nutrients, and I think Rich McDowell, who's scheduled to speak next, the research director of Land and Water, will be focusing in on this when he's here. So again, this is the current, and again, this is Rich's domain, but our current state of fresh versus freshwater objectives. So this is the nutrients. There's a lot of attributes in these data sets. And there's a lot of maps. So you might have seen some of this. Oh, here's Rich now. You might have seen some of this. It was released. There was a press release earlier in the year on this. This is some of Tom Snelder's work, looking at the excess nitrogen and yield and as a load in catchments around the country. It was actually created. It got quite a lot of media play, quite a lot of attention, and it's really important. This is really important stuff. Now, given that my awa is the Pariora in South Canterbury, this is of grave concern to me because those coastal rivers in Canterbury are under a huge amount of pressure, and this reflects the reality of what I see and have seen progressively developing in that landscape over the last 20 or 30 years. And similarly for E. coli, these are challenging maps, and this does no more than reiterate the challenges ahead of us as a country and as an industry, as an agricultural industry. So again, some of the guidance we've provided around where we think these data are most appropriately used, and instances where maybe it's not appropriate to apply them. Clearly, on a paddock-to-paddock comparison, these data are not really appropriate. There's quite a bit of climate change data in here as well. And some of the specific layers, so maize I won't talk about, pasture I'll talk about a little bit, and there's some animal stuff in there as well, and we've just plotted the various climate change scenarios there for your amusement. Clearly RCP 2.6, I think most people who are aware of how this is travelling have flagged that goodbye. 4.5 is aspirational, 6 is looking more and more likely, and there are still some pessimists among us who consider that 6 might be optimistic as well. In any case, these are challenges ahead of us, and many of the data sets will refer specifically to those climate change scenarios, and we've modelled all of them separately. So, future climate suitability for kiwi fruit under RCP 8.5. Well, I don't need to describe what's on the maps there. There are some areas which get better, and some areas get worse for kiwi fruit as we get closer to the end of the century. We do this not just for kiwi fruit, but here's an example of a whole lot of data layers that were done for wine grapes as well, including all of the climate change scenarios mentioned before, including 8.5 and current scenarios too. Right, I feel safe now. I'm back in pasture land. I really, really like this. Well, I was going to say, call it a data set. It's a set of sets. This was done as an APSIM simulation. So perhaps, arguably, the most sophisticated pasture model that we have. So, thanks, Kenny. All models are wrong, but this is again in terms of the ability to think about pasture production relativity is really important. So this is these maps are plotted at a 50 metre pixel size. So you can imagine these data sets are vast, and there's been data that's been upscaled and downscaled appropriately to get these models to run. But clearly you can see that under that climate change scenario, late century, we're going to grow more grass in many areas, and less in some. But this is with rain-fed and with no fertiliser, and it's the absolute values here. You can see the scale goes to 35 tonnes of dry matter per hectare per year. That's a nonsense, but it's the relativity which is important here. And I'll come back to the pastures in a little bit as well. This in the pastures data set, as I say, it's like a 2 gigabyte GIS layer. It's a ridiculous thing. If you just want to cut out a catchment, that requires some computing horsepower, but absolutely worth it. So Barber's poleworm, you can see that currently we've got some high-risk areas for Barber poleworm in the northern North Island, but we also face an increasing risk in far larger parts of the North Island and into the South Island in the future. So is this something we should be breeding for now? Heat stress for dairy cows. My neighbour is a rural banker, and he had a group of his staff come to him talking about heat stress in dairy cows. He flatly refused to even consider that topic of conversation. It was ridiculous, totally irrelevant, pointless. Until he was coming back from holiday in the Coromandel and saw a group of dairy cows huddling under the single tree in that paddock on summer's afternoon. And suddenly it's very much front and central for not only his bank, but for the industry as a whole. Not only from a production perspective, which is his principal concern, but clearly from a welfare perspective as well. And it's just going to get worse, right? We can talk about erosion. We all know that New Zealand is a very erosion-prone country. Some of those east coast rivers particularly have a higher sediment load of any waterways in the world, really. Lucky us. We can talk about where that sediment is coming from, and we can talk about how that pattern changes into the future. So we've developed a model which is driven by rainfall, by some thinking around how the annual flood frequency changes, and also the frequency of storms that drive those. And this is the sort of result we can get. So again, another layer which is unlikely to be appropriate at a paddock-to-paddock scale, but potentially becoming really important when you start thinking about catchment-to-catchment scale. There are clearly, as we go forward under different climate change scenarios, there are some catchments which will do better, and many catchments which will be considerably worse without other changes. So we've talked about barb poleworm. There's also facial eczema in that data set. That's all bad news, I'm afraid. So just to sum up then, what you'll find in the data supermarket, maps, tables, reports, lots of other documents, and the database is searchable. So there's a list, a short list, it's not inclusive, not exhaustive, of all the things that are in there. What I'm hoping is that in the last 5 minutes, we might go live and have a quick look at it, yeah? But before we do, are there any, just top of mind, are there any specific data sets that, providing the technology allows, you want to look for? This is a supermarket. It's free.
Do you have anything on E. coli?
Yes. I'm just going to scribble these down. E. coli. Anything else?
Chestnuts.
Chestnuts. That old chestnut.
Have you got trees in there, one?
There are. Come on. Which tree? Give me a tree.
Totara. Hazelnut.
Totara. Hazelnuts. Okay.
Do you have to search by subject, or could you go to a catchment or a farm and say, what would be useful for this area?
That's a good question. I don't know the answer to that. I'm going to have to ask.
Freshwater sites at community and culture.
I've only got 3 minutes.
Can you ask what the optimum land uses are?
At a given location, this is kind of the farm context thing. This is a really good question. Alt tab. So, if we go to here, I've searched for this before. Who's using Bing? Ugh. Land use opportunities. This is what it looks like, right? So there's, we're not going to go to the guidance documents in the terms of use. Let's go straight to the data sets. And here, okay, yes, I have read and accepted all of that. And I definitely have read that too. And this is what you're faced with. So 94 data sets. Let's go for E. coli to start with how it's going to be. Current state versus, in fact, this is probably a question that Rich is best to answer, but here's what we've got. There are 5 data sets which are relevant in the E. coli space. Current state versus those objectives. If we get into here, so this is a shape file. I don't have a GIS loaded, so this is a description of what's in there, but I'm hazarding a guess here would see that you don't have ArcView currently loaded.
I don't even know what I'm talking about.
Right. But there's a description of what's there, so there's quite a bit of E. coli stuff.
So
Okay.
you need to have GIS to view the maps.
Sometimes there'll be so if we go, where do we go there again? Let's go there again, and it should be there. So there's a map. So there's a kind of a crude scale, national level map that you can copy and paste and do a screen dump or whatever else. But if I just want to cut one of those catchments out at its native resolution, I need GIS to manipulate that.
But
And
you could look at this to decide if you need to.
absolutely, yep, that's exactly what it's there for. Yeah, so that's right.
There is an integrated map where you look at different catchment by catchment basis and things, the amount of pressure and how much you can leave that pressure by mitigations.
So if you ask Rich nicely at lunchtime, and if he's got GIS loaded,
Yes.
if it doesn't need it, okay. So we might be able to have a look at that later. Let's go back one and look at how much time have I got left? We'll see.
2 minutes.
Okay, so I'm going to look at hazelnuts because it's crazy, right? 2 sets for hazelnuts: crop growing requirements and let's just ignore that one for a moment. So here's the crop growing requirements. It's a table. So if I can. And so here's a description of the crop growing requirements of hazelnuts. So it's clearly nowhere near as fully developed as the kiwi fruit layers, for example, but there is some information in there. The last one is, what's the last one I was going to have a look at was cultural. That's interesting. I have no idea what this is. Easy access to detailed information on Māori traditional uses of New Zealand native plants and other organisms. Okay, so it's a link to to other pages. So, as you can see, like any supermarket, there is a lot of some things and not very much of others. But I hope that within those 94 data sets, tables and reports, that there'll be something that will enable you and your clients to make better informed, more timely decisions for their thinking about land use and land use opportunities.